Welcome to the project demonstration of high efficiency single stage onboard charger for electrical vehicles. So here the main advantage with this system is instead of charging with external clamp circuits, here no need of any external clamp circuits. Directly by providing the 230 volts AC input to this, it will present inside the vehicle, EV vehicle, electrical vehicle, and it's a battery section, and this is a totally onboard charging circuit, and we are using these two loads for just load application purpose, LEDs as well as a DC motor. So here the onboard charging works like by providing the 230 volts AC input. Directly this system will convert AC to DC with the help of this rectifier circuit, and then after using this high frequency transformer, here microcontroller will convert the DC to high frequency AC, and it will transfer to the rectifier circuit. This rectifier will rectify that AC to DC, high frequency AC to DC voltage, which is sufficient to charge our 12 volt 3 amp battery pack. So this is the rectifier section, and this is going to be the AC input to the circuit. So it has a stages like rectification. First of all means we need to convert the AC to DC, and then after with the help of this inductor, thus that pulsating DC will be converted into the pure DC voltage, and then after this full bridge inverting circuits will convert the AC DC to AC signal. So after this high frequency transformer circuits, we are going to maintain the current, and that will be converted into the DC with the help of this full bridge rectifier circuits. Here both inverting circuit and rectifier circuit will get the trigger pulse from our PIC microcontroller. We are using PIC 16F72 microcontroller, and which will generate the stereo signals to these two sections. One is the inverting section, rectifier section, and after that the rectifier section will provide us a DC of 12 volts battery charging voltage, that is 14.5 volts, because when you want to charge a battery of 12 volts, then we need to provide the 14.5 volts constant current voltage, then only we can charge this battery. So when we on the power supply to the transformer, this microcontroller as well as to this AC inputs, then the microcontroller start blinks this LED two times, then after it start producing the signal to this inverting circuit as well as the rectifier circuit, then the battery start charging. So if you want to make the battery fully charged, so it will take around of 6 to 8 hours. For the demonstration purpose, we are using the low current rating. In real time, we can go up to high current ratings. Then we can charge a battery in a less time, that is around of 20 to 30 minutes of time to charge a full battery. So here we are using 12 volts 3 amp battery. Coming to this battery pack, it has a 3 sub battery packs. Each sub battery pack consists of 3 4 volt 1 amp batteries are in series. So we will get 12 volt 1 amp here, and 12 volt 1 amp and 12 volt 1 amp. These three are in parallel, so we will get 12 volt 2 amp. So for application utilization purpose, we are making use of a DC motor rotation purpose as well as high power LEDs for lighting purpose. So just let us see the demonstration. You can on this 230 volts. While demonstration, you should take care of it's not supposed to touch on this board. The board consists of around 180 volts and 250 volts maximum. Just when you on this, the light will on and off 2 times, then it starts producing the voltage. If you want to check the voltage, directly you can check from these wires, which will provide up to the 14.5 to 18 volts maximum based on the trigger pulse input from the microcontroller directly. This application purpose on this one. And coming to the MOSFET ratings, we are using IRF G44 MOSFETs, and in this HBridge one we are using IRF 540 and IRF 9540. It's N channel and P channel MOSFETs, which is used to rectification purpose to convert the high frequency AC to high frequency DC power supply.